Well, we've got a big topic tonight on calculating monthly payments. Now, this is going to be very wordy and very calculator active, so pause it and grab that calculator. So first and foremost, I want to review an equation that you have to have memorized. It is not on your formula sheet. So we've used the formula sheet in class several times now, and you have it for the test, and you'll notice this is not on there. Why? I couldn't tell you, but they think you should memorize this. So I wouldn't not expect this to be given. You're going to have to look for this keyword and know what formula goes with it. So again, this is just a review. We've done this before. The formula for compounded continuously is A equals PE to the RT. Okay, and we said PERT to help you remember it, PE to the RT. So I want to remind you of a few things. A, let's get it in our notebook, is our final amount. P is our initial amount. E is literally the number E, Euler's number. R is obviously your rate of growth or decay. And T is your time. Okay, so compounded continuously is PERT. So here's our little warm-up problem. When Kyle was born, his grandparents invested $5,000 in a college fund that paid 4% compounded continuously. Okay, so ding, ding, ding. There is what's got to jump out at you. Get your highlighter and let's get going. Compounded continuously. Okay, I want to repeat. They are probably not going to give you this formula. You have to know that. Okay? So let's pretend that's not in there. We've got to catch the words compounded continuously. So here's the question. How long will it take to the nearest year for the investment to reach $8,000? So first of all, what is the question asking for? How long will it take? If I want to know how long something takes, I'm looking for the time. So let's jot down, we're looking for the time. And it does say nearest year, so we'll round appropriately. What is the initial amount of the investment? So he invested $5,000. So in the PERT formula, they call that P. Remember, E is Euler's number. That's a button on your calculator, 2.718, etc. My rate is 4%. So what am I going to use as my rate? Move that decimal 2 places, 0.04. And my final amount is that 8,000. Okay, so once you identify everybody in the problem, now hopefully the math is the easy part. So let's start with our PERT formula. A equals PE to the RT. The amount I want it to reach, we just said, is $8,000. When I initially invest $5,000, and that's 0.04 to the T. All right, so this is where that calculator is going to come in handy. I want to remind you, box things in. This exponent T is attached to only this term. That means I need to boot everybody else to the other side. So clearly there's a times here. I'm going to divide out my 5,000. And I'm going to do a little mental math. I'm going to kill those zeros. And 8 divided by 5 is 1.6 e to the 0.04 t. Now how do you solve an exponential equation? Again, I know it's exponential because the variable's in the exponent. The only way to solve exponential is to take the log of both sides. Again, you can use common log, log, or natural log, ln. And I'm going to use the natural log of this side, so the natural log of 1.6. And again, the whole point of taking the natural log of this side is that that exponent is going to go down in front. So 0.04t ln of e. Okay, so again, I'm putting the ln in front of each side, basically, so that's who I'm taking the ln of, and the exponent goes in front. So now my goal is to get t by itself. So I'm just going to move things over one at a time. I'm first going to divide by the ln of e. Okay. And I'm going to get some nice decimal, and I'm going to store that into alpha a. So grab your calculator, write down your decimal, and that's equal to 0.04t. And then I'm going to take both sides, and I'm going to divide by 0.04. And it did say round to the nearest year, so as I'm looking at my calculator, I'm going to say that's 12 years. All right, now if you remember back to class, we spent a lot of time talking about mortgages. You each picked out a house, you picked out a career, you went and you saw if you could afford the house that you picked out. So in this case, when they talk about mortgage payments, they're usually going to give you some sort of formula. Now, the interesting part is it's not always the same formula. So they're going to give you a lot of detailed information where you have to pick it apart and identify all the players before you can actually write the equation out. So let's slow down and read this problem. The monthly mortgage payments can be calculated according to this formula, where M, now here's where they tell you the players, M is the size of the mortgage, N is the number of compounds per year, T is the length of the mortgage in years, and P is actually this formula, where R is the interest rate as a decimal. Okay, so they identify in words all the players. Now we got to read it and figure out who's going to go where. What would the monthly mortgage payment be? So who was monthly mortgage payment? Okay, well that's what the formula is asking. So that's that's A. On $180,000, $15-year mortgage with 6% interest compounded monthly. All right, so again, we're going to go off to the side. We're going to identify all the players. M is the size of the mortgage. So how much of a mortgage are you taking out? Well, we're going to take out $180,000 for this house. Okay, so I just read them and cross them off as I go. N is the number of compounds per year, compounded monthly. So what do you think monthly means? Well, again, this is just review, so hopefully you know that it means 12. As a side note, let's talk about the words compounding anyway. Annually, if something happens annually, it happens once. So again, you should be putting this in your notebook. Semi-annually means it happens twice a year. Quarterly, think of how many quarters are in the school year, 4. And monthly, how many months in a year? I would say 12. So those are the key numbers you want to know for compounding. R is the length of the mortgage. How long are you taking this out? Well, it says you're taking it out for T is the length of the mortgage. We're taking it out for 15 years. R is the interest rate as a decimal. It said 6%, so my R is going to be 0.06. And then you got to figure out what this random P is. So P equals 1 plus the R, which is 0.06, divided by the N, which is 12. And I'm going to calculate that. So in my calculator, 1 plus 0.06 divided by 12, I get 1.005. Whew. So these are not easy questions, and they'll probably be like a 4-point question or a 6-point question. But anyways, now that I have all the players, I'm going to plug them into that formula that was given. Okay, so A equals M times P to the NT times 1 minus P all over 1 minus P to the NT. So that was the given formula. So now I just need to slow down and plug everybody in. So my amount equals my M value, which was 180,000, times my P value, which is 1.005, raised to the NT, so that's going to be, what's my N? 12 times 15 times 1 minus P in parentheses, so 1 minus 1.005, all over 1 minus 1.005, and that NT is on the P, so raised to the 12 times 15. Whew. Okay, now this is actually very nice if you got this far, because notice the variable is already by itself. So all you literally have to do is type this in your calculator. Now, the only time that may be a problem is if you have the 83. If you have that 84, you're hitting alpha y equals, and you are just typing this in exactly how you see it. So pause it and try to do it. If you're one of the few with the 83, I highly suggest typing in the top, writing your answer down, type in the bottom, write your answer down, and divide separately. Okay, but if you have the 84, use that fraction tool and just carefully type that in, alpha y equals, numerator, denominator, and hopefully you're getting, and again, if you're not trying it on your own, you're only hurting yourself here, 1518.9422, and I believe it said to the nearest dollar, so I'm going to say $1,519 is my monthly mortgage payment. All right, 2. Again, a monthly mortgage question. Now look, this formula looks completely different. And that's probably what they're going to do to you. They're going to give you all these different formulas to use because they want to know, can you read and follow directions? So they identify the players here. So they give you the formula, identify the players, and then they'll give you the scenario. The Banks family would like to borrow $120,000 to purchase a home. They qualify for an annual interest rate of 4.8%. Algebraically determine the fewest number of whole years the Banks family would need to include the mortgage agreement in order to have a monthly payment of no more than $720. All right, so let's get our players listed. I want to borrow $120,000. So I'm going to say that's my p-value. Amount borrowed. Bam. Interest rate is 4.8%, but we don't want a percentage. We want a decimal, so that's 0.048. Number of monthly payments. Well, I think that's what they're asking. Find the fewest number of whole years. So how many monthly payments? That's what I'm looking for. That's my N. And they don't want my monthly payment to be more than $720. So now sometimes that confuses people and they want to put they want to guess their own number. You have to use $720. You have to use the number they give you. Okay, and we'll round our answer accordingly. All right, so let's carefully plug this in. So my M, so I'm going to go 720 equals my P, so 120,000 times my rate, 0.048 over 12, times 1 plus 0.048 over 12 to the N, all over 1 plus 0.048 over 12 to the N minus 1. Whew. Okay, now this one is not as easy. And I think it's obvious why it's not as easy. The N is not by itself. It's not sitting here by itself. The N is attached to these as exponents. Yuck. Okay, but we're expected to be able to solve this. So let's talk about how we're going to be smart and clean it up. The more simplifying you do, the easier your life should be. Okay, so again, if you don't simplify, that's on you. The more you simplify, the easier it should be. So clearly, 720, there's nothing to simplify. Can you multiply this by this? Are there any variables attached to it? Of course not. So literally type in your calculator, 120,000, parentheses, use your fraction tool, 0.048 divided by 12, close it up. And we're going to scratch that off and we're going to put in what number we get there. I got 480. So much nicer looking. Okay, now, this is some number I can type in my calculator and raise it to the N. So in my calculator, I'm doing 1 plus 0.048 divided by 12. Type it in. I get 1.004, and I'm raising that to the N. So it already looks a lot nicer just by being smart and cleaning it up. Same thing, I'm going to type this piece in the bottom and raise it to the N. Now, if you're quick, you'll notice those are the same, so you actually already know that answer. 1.004 to the N, and then you have minus 1. Okay, so it's still not beautiful, but it's definitely better looking. Let's get a big star. I think the easiest way to solve this is a little simple cross multiply. Okay, and anytime I see an equal sign between, two fractions, that's typically what we do is we cross multiply. So I'm going to take, this times this. I'm going to write it real nicely. 720 times 1.004 to the N minus 1 equals 480 times 1.004 to the N. Okay, so we're getting closer. So here's what I'm going to do. I'm going to distribute this, but you've got to be smart. You can't actually multiply these two together because this is attached to the N. So I'm really going to say it's 720 times 1.004 to the N minus 720 equals 480 times 1.004 to the N. So again, I want to stress you can't actually multiply those two together because this is attached to the N. Okay, now, remember, your goal is to put the like terms together. This is a like term with this. What do I mean by like terms? They have the same base and exponent, so they're alike. So I'm going to say 720 times 1.004 to the n. And I'm going to bring this over, so minus 480 times 1.004 to the n equals a positive 720. Okay, I basically just kind of swap spaces. I move this guy this way and this guy this way. Now, because those are like terms, I'm just going to subtract their coefficients. So circle them for yourself. 720 minus 480 makes 240 times 1.004 to the n equals 720. And again, my goal is to get that n by itself, so now I'm going to divide both sides by that 240. Kill those zeros, so I really have 72 divided by 24 equals 3. I'm going to take the log of both sides, and again, the whole point of taking the log is that it'll take that exponent and move it in front. So n log of 1.004 equals the log of 3. And then I'll solve for n by just dividing that log out. And I get n equals 275.202, blah, blah, blah. Whew. Now you might be thinking that's kind of an absurd answer because the question said, if I recall through all this math, what is the fewest number of years? So you're telling me it's going to take this family 275 years to pay this off? Well, I'm not saying that because if you look back and you look at n is the number of monthly payments. N is the number of monthly payments. So this answer is actually in months. Now they were sneaky and they said, okay, well, what is the answer then in years? Since you're giving us the answer in months, I need that answer in years. So I'm really just going to divide this by 12, and I'm going to say it's going to take 22.933 or 23 years. All right, well, we're going to try another one. So this is another example they gave us as a practice question, and again, the formula is different again. So using the formula below, determine the monthly payment on a 3-year car loan with a monthly percentage of 0.75% for a car that originally cost $25,000 and a $2,000 down payment to the nearest cent. Okay, so again, here's all the game players in their formula. Now, this one required you to think a little. Notice, the car costs $25,000 and you're putting a down payment of $2,000 down. So P sub n represents the amount you're borrowing. Are you actually borrowing $25,000? No, and I hope you've caught that. If you're putting down a down payment of $2,000, then you're only borrowing $23,000. The number of monthly payments. Well, notice they said it's a 3-year car loan. So don't fall in that bear trap. Those don't match up. 3 years is not the number of monthly payments. If I'm going to go 3 years at 12 months per year, my number of monthly payments is going to be 36 years. The PMT stands for the monthly payment, and I believe that's the question, determine the monthly payment. So I'm going to put a question mark. We shouldn't know that one. And I is the interest rate. Notice, they're sneaky again. What they give you is a percentage, not the rate. Okay, the actual rate, we're going to be at 2 decimal places, of course, so 0.0075. Okay, so now that we've identified the players, let's slow down and let's plug them into that formula. So P sub n, so 23,000 equals my monthly payment, so I'm going to call that my PMT. And 1 minus, parenthesis, 1 minus 0.0075 to the negative 36 all over 0.0075 and close that parenthesis up. Okay, now I actually consider this one fairly easy to solve. My goal is just to get this by itself. Is this not something you can type in your calculator? All right, so I want you to type that in your calculator, and we'll get some number there. So I'm going to have my payment times A, I'm going to call it whatever you get in your calculator, and then clearly you're just going to take that amount and divide it over and you will get your payment. Well, I think that does it for us. These are intense problems with a lot of reading and a lot of mathematical room for error. So I think the question we did before this is probably the toughest. So feel free to go back and rewatch and rewind and practice with your calculator because we do need to be pretty good at these. Have a great night.